Welcome to Episode 33, Pre-Trained APIs, Vision, Language, Speech, where we explore how Google's pre-built artificial intelligence services accelerate development without the heavy lift of custom modeling. Pre-trained application programming interfaces, or APIs, deliver advanced capabilities, image recognition, text understanding, and voice processing through simple calls. They let teams integrate intelligence fast, focusing on business logic instead of machine learning infrastructure. These APIs are continuously improved by Google's research and scaled globally, giving organizations instant access to state-of-the-art models. Yet speed comes with responsibility. Developers must still validate quality, protect privacy, and control costs. In this episode, we'll unpack how each service works, where they shine, and how to combine them into reliable, ethical pipelines that deliver insight at production speed. The Vision API enables systems to see and interpret visual information. It can detect objects, classify scenes, extract text, and even recognize landmarks or logos. These features support diverse use cases, from automating document processing to powering image search and quality inspection. For instance, a retailer might analyze shelf photos to verify product placement automatically, while a logistics company extracts text from labels to speed warehouse operations. The Vision API's strength lies in broad generalization across millions of image patterns, making it ideal for standard visual tasks. However, it is not infallible. Image context, lighting, and resolution still affect accuracy. Responsible use means setting confidence thresholds, handling uncertain results carefully, and incorporating human review where visual decisions carry consequences. Natural language services provide comprehension at scale, turning unstructured text into structured understanding. Google's Natural Language API can classify documents by topic, extract entities like people or places, analyze sentiment, and summarize content. Combined with translation tools, it supports multilingual analysis across global operations. For example, a support center might use it to categorize incoming messages, detect urgency, and route them to the right team. Pre-trained models excel at general language patterns, but can miss nuances specific to industry jargon or tone. The solution is context tuning through custom metadata or combining API outputs with internal rules. The result is accelerated understanding without reinventing the linguistic wheel, enabling organizations to act on written feedback, reviews, and communication streams in near real time. Multimodal pipelines combine vision, language, and speech APIs to solve complex cross-sensory problems. Imagine processing a video. The Vision API detects objects, speech-to-text transcribes dialogue, and the Natural Language API extracts topics. Together, they produce searchable, structured summaries of visual and spoken content. This synergy powers compliance monitoring, content moderation, and media analytics at scale. For example, a broadcaster can scan archived footage for brand logos, spoken mentions, and sentiment simultaneously. Designing these pipelines requires consistent metadata formats and latency awareness, so each service complements the others. When coordinated properly, multimodal analysis unlocks holistic understanding, systems that see, hear, and read together to create richer context and faster decisions. Request patterns determine performance and cost. The choice between batching and streaming depends on workflow demands. Batching suits offline processing, large sets of images, audio, or documents sent in groups for efficiency. Streaming enables real-time interaction, such as live captioning or instant translation. For example, a customer support platform might stream audio for immediate transcription while periodically batching logs for analytics. Managing request size and frequency prevents quota limits and optimizes throughput. Proper batching also reduces network overhead, which is vital for high-volume operations. Understanding these patterns keeps systems responsive and affordable, balancing user experience against processing scale and timing. Quality levers fine-tune API output, helping models perform closer to real-world needs. Hints and context guide the model by supplying domain information, such as expected vocabulary or label sets. Adaptation allows custom tuning based on representative examples. For instance, a healthcare provider can upload medical terms so speech recognition handles diagnoses accurately. Or a content platform can specify category lists to improve text classification. These adjustments turn generic intelligence into domain-aligned performance without retraining the model. The key is iterative testing. Observe errors, refine hints, and measure improvement. Quality control through context and adaptation ensures pre-trained services evolve into fit-for-purpose components rather than generic helpers. Handling personally identifiable information, or PII, and sensitive content responsibly is non-negotiable. API calls may involve customer names, voices, or visual identifiers that fall under privacy law. Developers must anonymize data where possible, restrict retention, and apply encryption in transit and storage. For example, blurring faces before image analysis or masking PII in transcripts preserves compliance while maintaining utility. Google provides data loss prevention tools and redaction features to automate this step. The misconception is that using a managed service transfers all liability. In fact, responsibility for lawful use remains with the data controller. Privacy governance must accompany every deployment, ensuring transparency, consent, and user trust throughout the data lifecycle. Operational constraints like quotas, latency, and regional availability influence architecture. Each API has default rate limits, adjustable through quota requests. Latency varies by model complexity and network path, so region selection matters. Deploying workloads near data sources reduces delay and complies with locality rules. For instance, European operations may prefer EU-based endpoints to meet data residency expectations. Testing under realistic load reveals true response times and scaling behavior. Engineers should also plan fallback mechanisms for rate limit errors or outages. Understanding these operational levers keeps pipelines resilient, delivering steady performance under variable demand without breaching service thresholds. Testing datasets and acceptance thresholds define whether API outputs are good enough for production. Benchmarking against labeled validation data establishes baseline accuracy and confidence intervals. For example, evaluating entity extraction on 100 sample documents may reveal which categories need adjustment or manual review. Acceptance thresholds should align with business tolerance. 95% accuracy might suffice for internal search, but not for legal evidence. Continuous evaluation detects drift as input patterns change over time. Testing transforms assumptions into evidence, ensuring that automation complements human oversight rather than replacing it prematurely. Post-processing and human review loops turn raw API output into actionable results. Machine-generated text, labels, or transcriptions often need cleaning, deduplication, or scoring before use. Human reviewers validate uncertain cases, improving quality and retraining future models. For example, a media moderation system might automatically flag potential violations, then route borderline items to reviewers who confirm or dismiss the alert. Review data can feed adaptive filtering, steadily improving accuracy. This balance of automation and human judgment keeps quality high and accountability visible. When combined thoughtfully, post-processing and feedback loops make machine intelligence auditable, maintainable, and continuously improving. Cost forecasting and throttling strategies prevent runaway spending. API billing typically depends on units processed per image, character, or audio minute, so usage monitoring is essential. Forecasting based on historical traffic helps budget accurately, while throttling enforces limits during surges. For example, setting a daily processing cap or queue threshold avoids exceeding cost ceilings during unexpected spikes. Compression, sampling, and prioritization can also reduce cost without major accuracy loss. The misconception is that pay-as-you-go billing ensures affordability automatically. Disciplined monitoring is still required. Effective cost control turns API integration into a sustainable service rather than an open-ended expense. Common use cases demonstrate how pre-trained APIs accelerate productivity across industries. In healthcare, they assist with document digitization and voice transcription. In retail, they analyze shelf images and extract insights from customer reviews. In media, they automate captioning, moderation, and metadata tagging. Anti-patterns occur when teams overextend these APIs, forcing them to handle niche data without adaptation, or using them as black boxes without evaluation. The lesson is clear. Use pre-trained APIs where they fit naturally, and augment them with business logic where needed. Responsible boundaries maintain performance and protect users from hidden errors. Speed with responsible guardrails defines success when using pre-trained APIs. They deliver immense leverage, instant capability backed by global infrastructure, but still require human judgment, validation, and ethical awareness. The smartest teams treat them as accelerators, not replacements for understanding. By combining proper testing, privacy discipline, and cost control, organizations can scale quickly while staying trustworthy. The future of AI is not only about speed, but also stewardship, deploying powerful tools with clarity of purpose, respect for users, and accountability for outcomes. With that balance, pre-trained APIs become engines of progress that serve both efficiency and responsibility. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.